Let's solve this linear programming problem using the simplex method. The first thing we'll do is to write our initial system. Remember, our initial system is the one where we add our slack variables and we rearrange our objective function. So if I look at my constraints, the first one, I'll have x1 plus x2. I will add the slack variable s1, leave some space, equals 5. Now I move to my second constraint, 5x1 plus x2 plus another slack variable equals 9. Now we will rewrite our objective function by subtracting the terms with the decision variables from both sides. That will put me with negative 20 x1, negative 10 x2 plus p equals 0. And of course, in our initial system, x1, x2, s1, and s2, all of these are greater than or equal to 0. We use this system to write our initial simplex tableau. Label your columns with your variables. And leave a column for the right-hand side. Okay, here's our initial simplex tableau. Now we look for our most negative in the bottom row. That's this one. Remember, we are not choosing this because it's first. We are choosing it because it is the negative number that's largest in magnitude. Now we move over to the right and calculate quotients. So we take each of the right-hand side numbers and divide them by non-negative numbers that are in the pivot column. So I do 5 divided by 1 is 5, and then I do 9 divided by 5, and you'll want to switch this to a mixed number, so this will be 1 4/5. This is the smallest quotient, so this is what we choose for our pivot row. So we circle our pivot row. And in our pivot operation, what we want to do is we want to get this number to be a 1, that pivot element, and then everything else in that column will be replaced by a 0. That's our goal. And we're going to do that by doing row operations. So first we're going to multiply by this reciprocal of that element in the second row, so this will be 1/5. Row 2, we'll put it into row 2. So my first row remains unchanged. And then my last row remains unchanged also. Okay, and so now we want to get zeros in these other two positions. Remember that you're going to take the opposite of that number. So this first one, you have to remember which one is the pivot. element. Let's highlight it. You just want to make sure that you don't get mixed up about which column contains that one that we placed there deliberately that we are calling a leading one. So in order to turn that first row into a 0, we're going to take the opposite of the number that's there, so that'll be -1. We're going to multiply by the row that used to have the row that has the leading one, which is the one that contains our pivot element. That would be row 2, and we're going to add it to the first row and then put it back into the first row. So when we do that, we will have 0, 4/5, 1, then -1/5, 0, and 16/5. Second row is still here. And then on my third row, I'm going to take the opposite of the number that's there, so that's +20 times the row with the leading one, which is row 2. And then add that third row back into the third row. When you carry out that row operation, you should end up with a 0, -6, 0, 4, 1, 36. Now, how do we decide if we keep going? We look to see if there are any more negatives on the bottom row. And there are. Okay. So here we look for the most negative on the bottom row. That tells me which column is my pivot column. Then I come to the other side and I calculate my quotients. So here I will have 16/5, which I'll divide by 4/5, which will give me 16/4, which is 4. Then in the second row I have 9/5 divided by 1/5, which is 9/1, or 9. We're going to choose the smallest, so this will be that first row. So I'm going to use that for my pivot column, and so then here is my pivot element right here. And now once again we do row operations to get a 1 in that position and zeros elsewhere in that column. Okay, in other words, we want to get a 1 here, and then we want to get zeros elsewhere in that column. Okay, so once again, here I'll do get the 1 first, then I'll get the zeros. So I'll do 5/4 times row 1, and I'll put it into row 1. So that'll give me 0, 1, 5/4, -1/4, 0, and 4. I'm going to recopy the other two rows for now. As I mentioned before, you'll definitely want to investigate using some technology to perform the pivot operation for you. But we're doing it here to make sure that you get a little practice in seeing it and in working it out for yourself. Okay, so now we need to let me highlight my pivot element again, which is right here. This is the element that I just turned into a 1. And so that means I need to get zeros here. So I will do negative 1/5 times the row with the leading 1, add to row 2, and I will do positive 6 times the row with the leading 1, add to row 3, into row 3. Here's what we get. Okay, now how do we decide if we are done? There are no more negative numbers on the bottom row. And so that means we are finished pivoting, and we just need to write the solution. Okay, so we have finished pivoting. Now we need to write the solution. Let's go back and make sure that we have our original variables written onto our matrix. So x1, x2, s1, s2, p, and then of course our right-hand side. What variables are being set equal to 0? These we call non-basic, remember. Here we look for the columns that have the junk in them. In other words, a bunch of other stuff. It does not look like columns from an identity matrix. That would be S1 and S2. Notice your P, your objective function column, will always be a basic variable. That column will always look like the column of an identity matrix. And the right-hand side is not a variable, so we don't think of that as a column with junk in it that'll be set equal to 0. So in this case, S1 and S2 are getting set equal to 0. That means my first row will give me 0 x1 plus 1 x2 plus 5/4 s1 minus 1/4 s2 plus 0p equals 4. You're not going to write this every time. We're just going to do it once or twice here to make sure we understand. So 0x1, that goes away. Here we have x2, but here the 5/4, the s1 is getting set equal to 0. So is the s2. So these terms will also drop out. The 0 times p is also gone. And so now we have simply x2 is equal to 4. Do you see how you can read that right off the matrix? X2 is equal to 4. Now what about the next row? X1, see, there's the 1 in that X1 column, is equal to 1. So row 2 tells me that X1 is equal to 1. And then the third row tells me that P is equal to 60. So my solution is, make sure that you give the maximum value of your objective function. So we're going to give P equals 60. And this is going to occur when x1 is equal to 1 and x2 is equal to 4. That's the solution to our problem.